Sure. So first of all, I want to just take this opportunity to convey my thanks to Director Ma'am and HOD Sir, Dr. Ramakanji, and also to uh, faculty sir, Sachin Sir and the other faculty members. So now just a quick about myself. So currently I'm working as a technical lead in the Cognizant Technology Solutions Singapore, and I'm having around 10 years of industry experience with various technologies. Mostly it's around the data, big data and data science projects. So I have already delivered so many ETL projects, big data projects and data science projects. So for today actually I will just going to share my experience and some raise on the what is the currently industry needed from new students and beginners, and how they can land their jobs in the big data industry. Okay, so just before going to talk on the big data, I'll just want to this discussion to be more interactive and two-way. So our this whatever I will ask some question or some discussion. So I'll just request to all the joinees, just convey your message, whatever your understanding, whatever your things on that topic, so that it will be more interactive between two-way communications. So before just starting, I just want a quick, responses in a one-liner responses from the audience. What you are, understanding about the big data? What you understand with the big data? How means what is your feeling on the big data? How you can, say what is the big data thing? Just quick response from the students.
Sorry.
Please write on the chat box, in the chat box, one liner. What is
Yeah,
the
yeah,
meaning
yeah,
of big data?
yeah,
Students,
yeah.
reply, quick reply, please.
Whatever your things, it's not about the judging your knowledge. It's just how what is your understanding. Okay.
Yes, we are getting the answers.
Quick, guys. Yeah, yeah. Huge amount of information having relevant data. Sagar Gupta replied, Rasmi Soni, large amount of data. Great. So this is the one feature. All of you very good. So big data is definitely is a data is big. But before just starting a session, uh, going to the next slides, I'll just show you something. I hope right now you people are seeing my the black screen, right?
No, no, the same screen,
First
sir.
screen. First screen.
Okay,
That is
okay,
the.
okay. Just let me.
Yes.
Is it coming now?
No,
No.
no, the sir.
Okay. Hmm, eh, It's okay. No problem. Let's continue with this. I'll continue with this. So just before starting, hello.
Now it's visible.
Yeah, it's visual. Okay. So guys, just I want to introduce you what is the agenda for today. Okay. So the first, so I divided this section into two parts. The first part is the introduction of the big data. Here means we are not going to just scope for this is very limited. We are not going to very deep in this part. We will just see what is the big data and what are the solution we are using in the industries. What are the different solution we are using the different industries like Hadoop, Spark. Okay, and we will see some basic concept, means what is the special in those tools and frameworks and why we are using in the industry. And after that I will just explain you one hands-on demo on the Spark. Okay, so this is the technical aspect, and the next part will be we will discuss about means how you people can be ready for the industry and what are the prerequisite you should have before going to for the your interview in the industry. What are the learning path should be, and what are the different role we roles you have to play in the industry, like as a data developer, ETL developer, and data engineer. So we'll explain these things in the next part of that. Okay, so so but before starting that, I'm just give you some highlights on the what is the units of data. So we have seen in our curriculums, in our academics, right? We bit smallest unit of the data is the bit. Then after that it's the byte, then KB, and 1 KB kilobytes, MB, GB. Usually we have habitual to understand these terms like 1 GB, 1 TB. Okay, but let's go some beyond of these, means I'm just giving you these numbers so you can understand how much big data we are processing in this time in the industry. So there is a petabytes. So this is around 1024 TVs. Okay, so after that exabyte, then zettabyte, then etabyte, and then exonotabyte. So basically what I'll tell you in my experience, I have just processed till petabyte data, means in the industry. Okay, so I hope you are just get some these numbers. So these are not important in aspect to means your interview or something, but these are important just to I'll just give you this number so that you can correlate yourself and with the big data, means how big data is big. Okay, so these are the points. Let's see, understand means what is the meaning. I'm just connecting the your feeling of these numbers. Okay, if you see this one byte means it's something like a single character. Okay, now after that is a KB, it's a very short story. We can write a some very short story, some for example some text pad we are writing the notepad, some data in the notepads, means one paragraph, two paragraph, like that. After that it's MB, it's something like a one novel, or you can say lump sum around some small ebook or something like. After that GB can be picked up your truck filled with paper, something. So means a truck, whatever the a truck having the data in the papers, something like we can put that data in the 1 GB. Okay, in the terabyte, in aspect of terabyte, so it's around uh, 50K trees made into a paper, something like that. And after that petabyte, it's allowed, means it's something data is if talk about the volume of such data, means around all US academic research libraries should be like in come in the your 2 petabyte data. After that 5 exabyte data, it is something around all words ever spoken by the human beings. So now you can just relate yourself with the how huge this means these matrices are, means. So I'll tell you, I have already told that this time big data is dealing with petabytes of data. So you can understand how many huge volume of data we are processing. Okay, now before going to the next slide, I'll ask you one quick query. What type of what do you understand by the types of different datas? Guys, just quick response. So till now, whatever the I just told you the different numbers. Okay, just message. What you understand by the means data types, different types of datas. So I'm not asking this time, this is not a bit different to the programming data structures, data types like different array or something, char, int, that is not related to that. What are the different formats of data? Correct, correct. Good, good.
Similar. It's
So Ankit Sharma is very coming right answer. Audio, images, text, medium. Correct. So these are the different types of data actually. So if I go and in the common, in the general way, if I categorize these things, so it comes basically there are three category of these data. So we can divide into the unstructured data, semi-structured data, and structured data. Okay, so what do you mean by this unstructured, semi-structures, and these data? So, so basically, as we get responses, so unstructured data is your, this is like your, audio data. So, for example, audio, your videos, so those are coming into the unstructured data. Okay, so this is kind of your audios, and semi-structure is like we are using the Excel data, XML data. So such kind of data is your semi-structure. So semi-structure means somehow we have some level of the structures. Okay, and unstructures is totally there is a no structures. If I tell you the example in the structures data, so basically structured data is about the database, Oracle database, the database tables. Okay, so why those are structures? Because we have a defined structures, rows and columns. So if you want to retrieve some data from the database, you can just query, means I need data from such column. So for example, there is a employee data, and there is a employee name, salary, and department, like that. This is a very basic example. So if you want to fetch out some data, we will just select this employee name and we'll get the data. So it's a totally 100% structures data. Semi-structure means it's kind of Excel data. In Excel, we have somehow some pattern, like some column one, column two, column C, something like. In XML also, if you see the structure of the XML, we have some different attributes, the same element, root node, such kind of data. But unstructured is there is a no row, no column, nothing. So it is something like your dump data, text data, your audios, videos. So basically, what is this audio and video? These are totally your binary data on the storage perspective. So basically, these are three different categories of your data. Okay, so so now you people can say, okay, no, what's new in this? So the new in this, and why big data is so special, big data technologies, so we are going to use this. We have these structures in since long back. Okay, so that is correct. But the problem is that nowadays, as per the survey of the IBM, so since last 2 year, whatever data increase, that is the out of them is the 80% data is your unstructured data. So that is a quite so processing unstructured data is quite tough in comparison to the structures data. So tough in the sense, the first problem comes in the picture is the storage, how you store such huge data. So if I talk about before 10 years, there are no so much e-commerce sites, there are no so much social sites, right? But nowadays, the Twitters, the Facebook, if you see the tweets, so tweets is totally kind of the unstructured data. So such things are coming in picture, and to handle those data formats, we are going to take this big data technologies help. Okay, so I hope this is totally clear with you guys. What are the formats of the data? I just want a quick response, yes or no, guys. Just if you have any question, you can type it, or if you are clear with just quick yes or no. Great, great. So now just go into the next part of this our discussion. So I will discuss what are the some uh, conventional approaches which we are doing before coming this big data problems. So before that, we are doing for the storing a data, we are using the RDMSs like Oracle, DB2, MySQL, right? And the file system, I'll talk about the file system, means OS file system. It could be your Windows file system, it could be your Linux file system. Okay, so the file system, we are using the basically the storage, the files, and some binary formats of data. And to processing this, we have the SQL queries, and also apart from that, programming framework, we have the C, C++, Java, Python, Perl, such kind of programming framework. So I'll just give you the talk about the basic example. So suppose there is a database. In that database we have some data, employee data, and we want to select some employee information. So we have two ways. First way is just we go and quickly run the SQL query, select star from this table, and whatever your condition, filter condition, where close, and give it like that. We can get it that, right? This is the first way. Another way is we can do the same practice using the Java program or Python program or C program. Okay, we will write our program. Okay, we will write our connectivity between the for the in terms of the Java, we will write the JDBC program to connect our program with the database, and then will we fetch the data, and then we'll print in some file and put it like that. So this is the conventional approach. But now the question is, how you, if you have unstructured data. Unstructured data means you have a text data in the dump some file. Okay, then how you will process it? Okay, easily we can process using the some this programming framework like Python or Java. We can just read that file, and then somehow we will clean the data and get it like that. Okay, but this is the one thing. Now the question is, if you have a petabyte level of the data, then definitely your this procedural, or you can say this conventional programming framework will not give you such uh, result, such good results. Okay, maybe they will take means months to process that data. So this way we need the big data technology. So this is the things where we have to think how do we process these things. Okay, now so these are the conventional approaches. Now we will see what are the problems we have in our these approaches. Okay, so basically these are the problems what we are facing. The first thing is the limited storage capacity. Limited storage capacity means you are running, now you can say we already have servers, we can increase the RAM, we can increase the hard disk like petabyte or something. But the problem is that at such level you cannot increase such resources in a same system. Okay, for just yeah, here simple example. If you bought some i5 processor, Intel i5 processor. Okay, so how much RAM you can increase in that? For example, you can increase 60 GB, 32 GB. Okay, after that whatever the RAM you will add in that same system, you will get some notification like in that whenever you will go and see the system properties. So this amount of RAM is unusable. Unusable means your processor is not sufficient to consume such level of the RAM. So after some time, either you have next you have upgrade the processor, also go for the i7 i9 like that, so that you can build up some more resources on the top of the same processor. Such kind of problems will comes in the future. If you means at a certain level you cannot increase resources at a certain level, there is a saturation point will come, and you have to bottleneck to process your some either you purchase a new system, then process data on that. So but that is a very difficult to moving data one system to another system. Okay, so that is the another problem. So the second point, if you see, this is the no scalability. So this is what I have already discussed. Scalability means you cannot scale up as a particular whatever you want. Okay, so there is just some limits for scaling up your your systems, your resources. Okay, now the third point is the single point of failure. Single point of failure means running your servers, your master server is one, or you can say single machine, and if it got failed, then everything is screwed up. So this is the single point of failure. Now the problem, another is the sequential processing. Means, for example, if you have a very huge data, if you process it the sequential way, then it will take more time. But better is if you just divide it in some parts and run those sub parts of your main jobs and run in the parallel way. So that is the better approach. But in the conventional approaches, we cannot do this thing. So there is a no true parallel processing thing. Okay, and another major problem is RDMS. You can say that Oracle is very strong, we can update it, but that can handle only your structured data. So that is not possible to process your unstructured data or semi-structures. So further, definitely you have to go either conventional programming frameworks or the big data. So that's the problem. Another thing, requires pre-processing of data, definitely. So here is the example just to understand. So suppose you are going to process some unstructured data, then pre-processing data means you are applying some certain rules and some certain mm, rules and regulations on the top of the data. After that, whatever you will get, you will run that actual data with your program. So this is the kind of pre-processing. Pre-processing means cleaning up your data. For example, you dump the web data. So I'm just talking about the example, the unstructured data. So there is some web server, or you can say there is a sensor data. So whatever the satellites is running, they are sending a data in minutes, in seconds. So you have a huge sensor data and you have to process it. Then definitely you go and clean that data. Whatever you don't want, you just remove it from that, and then whatever the correct data you will get it, or you can say clean data you will get, you will process that particular data. So this is the pre-processing problem also there. Another thing, so information is collected according to the current business need. So whatever information you are you means information you are getting from your resource, these data resources, that is just for the current business need. What today we need, we are collecting like that, but we cannot thinking about the future. For example, after 5 years, how much data will come, and how much processing power needed. So for that, there is a no so much you know foresights. Okay, so uh, we have to think about it also. Maybe today we are consuming only, for example, 1000 TV data, but maybe tomorrow after that, because data is growing very rapidly. Okay, so that is the also problem with the conventional approaches. So now I'll give you one more points. So first thing, uh, another problem is the we have already discussed this limited storage and processing capacity. So what is the processing capacity? So that we have already discussed. Processing capacity means how to process that storage is one problem, processing is another problem. So for example, we have seen the conventional methods, we are using the Java, C++, such kind of programming framework. But here it is a problem with that also. Those are not so much scalable programming language. We cannot get it so much parallel processing with those. So that is the problem with that. Now it's again installed on the single machine with limits to storage and processing. This is also a kind of your single point of failure. Now again, the problem is requires to archive the data again. So I'll tell you one more thing. In the industry, actually, in the real times scenarios, we are not, whatever the data today we process, that is not going to uh, 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 destroy or we delete that data. We keep that data years of years. So there are certain, we have SLAs with the clients. Means they told us specifically, they tell us specifically that this data we needs archival for next 5 years or next 10 years. So you can imagine, we have just archived a data since last 10 years. Now today some query comes from your client. Okay, now they ask, I want such a data analysis on the data what we have ran and the 10 years before. Just give it the report on that. So it is very difficult to archive data, unarchive it. Okay, after that, put it into the your main processing wing and then process that data and then run your analysis. So that part is quite difficult in sense of processing and in sense of resource storage also. So now the problem is not in the storing the data. We can store everything, right? We can put more hard disk. Okay, for example, how much we can purchase, but the problem is the retrieval of the data. I just give you one simple example. So you have a very large bag. Okay, and you have a different type of fruits like orange, okay, apple, and etc. And storing, and someone asks you just store it. So it's very easy, you just pick it and just uh, you know uh, put it inside the bag. and again, for example, 100 mangoes, 100 guavas, 100 apples, 100 bananas, like that. You just put it and dump it in that. So it's very easy. But if someone asks you, okay, I want to retrieve one green mango, two yellow mangoes, and two red apples, then it is very difficult to searching in the huge space. Okay, so always the problem, don't think about the problem is the storage is one problem. Some way we can solve it with the old tools and technologies, old ways. But the main problem is retrieving the data, or you can say it's processing that data. So that's the problem. So for that you have some organized framework, so that now just same example what we have already discussed, just change it in the some another scenario. Now you have a bag, but it has some different compartments, and you put some levels over that. Okay, this is the apple block, this is the bananas block, this is the mangoes block, this is the green mango, this is the yellow mangoes, like that. And if someone now this other person is ask you, just okay, I want 10 red apples, two green uh, mangoes and two yellow mangoes. So you quickly just see the level and go and just collect it and give it back. So this is the you can just relate this thing. The same thing is happening with the data. So data is also important thing, is not storage is not one important thing. Another important thing is the retrieving the data, processing the data, and generating the your reports. So for this is the another problem which we face with the traditional uh, tools and technologies. Okay, so now people can ask, okay, so now we can just remove all the old technologies like Oracle database, and the does the big data is the can replace the old conventional approaches problems? No, it is not a replacement of that. It is the solution for the big data problems, but not the replacement of the other old scenarios, or what scenario is running. For some cases, definitely the your RDMS and your conventional approach is far better than your big data processing. But in some cases, we need big data. So it's not a replacement. It's just solution for some additional this big data problems. I hope it's clear. If you are following me, just a quick yes or no. Great. So okay, so just go another thing. So just an additional note here, just a side note. So in programming language, the data structures you people are learning, that is the like character, integer. So why those data structures defined in the programming languages, the most important reason for that also, retrieving the data. If we don't have such data structure, we cannot retrieve a data. We can store without data structure, but we cannot retrieve that. So that is the additional note on that. Okay, now I'll share with you some real-time Hadoop use cases. So I'm just don't this time you're no need to understand what is the Hadoop. Just see what are the use cases of the Hadoop. I will share some problems, what problems organizations address faced, and how they address those using the Hadoop framework. Okay, so this time you no need to understand the Hadoop. Just see what I am going to told you. I will discuss Hadoop in later subsequent part, and it's my guarantee you people will be very clear with the Hadoop. What is the Hadoop? What is the big data? Okay. So, but just sit with open mind. So see, I'll give you one example. This is a China mobile things. So the problem, if you see, the problem statement is storing the billions of mobile call records and providing the real-time access to the call records and billing information to customers. Okay, so traditional storage and database system couldn't scale to that loads and provides a cost-effective solution. Okay, now the problem was they have to different call records. So just example, you mostly we people have any problem with our telecom providers like Airtel, Vodafone, etc. So whatever we can go and call to our customer cares. Okay, now if you see how, so if I talk about the before 10 years, it was not so much data, such kind of data. Okay, so now they are going to calling daily basis, and what they want a real time access to the call records and billing information to the customers. Real time means real time means it's don't understand it. It's just what you any event you had trigger and just impact on that. It's some delay is very less. For example, in seconds or 2 seconds. So it's the correct term is the near real times. Okay, near real time means it's 5 seconds, 2 seconds later. Okay, so this is the, so they want such situation. Now I can ask you, can Oracle will solve such problem by RDMS? So just take a scenario. Okay, correct. Oracle is not so much, we cannot scale so much Oracle. We don't know. So today, suppose we get a 10 calls. For example, it's very tiny, but not 10 calls. So suppose we have today's 10 TB data. Tomorrow, maybe we get the double calls. So such scaling up your systems is a very problem. And that is not possible with that your traditional fashion. Okay, now what's the solution provided? Solution is the HBase. So I'll just here notes on the HBase. So HBase is a kind database. Okay, so it's a no SQL database. No SQL means doesn't means there is no SQL. SQL means SQL. There is a SQL, so it's kind of no SQL. It's a more than that. So NoSQL means it's a NoSQL more than that. It doesn't mean there is a NoSQL. There is a SQL. We write query and we retrieve the data, but it's a their own format to writing the query. So this is the HBase. So HBase is a part of the Hadoop. Okay, big data. So it's a NoSQL database. So they use that and they process it, and the vendor Hadoop bar that is the Intel, and the cluster size. I'll discuss with this what is the cluster. So cluster doesn't just understand. Cluster means set of nodes, and node is nothing. It's your one computer. So one, you can understand 100 plus node means they are using 100 plus computers, or you can say 100 plus machines to process such data. Okay, so I hope this use case you are clear with it. What was the problem and which tool we use with that. This time don't go into the deep means how it's then, just it's not required right now. Just I give you the heads up. Okay, so let's see another one more real time use case. So this is a use case from Nokia. So Nokia collects, analyze vast amount of data for the mobile phones. So first problem is dealing with 100 TB of structured data and 500 TB plus semi-structured data. So I have already discussed semi-structures means your such kind of XML data, your CSV data, Excel data, such kind of data. Okay, and tens of petabyte across Nokia, 1 TB per day. So tens of petabyte across Nokia. So across Nokia, I'm including in the all over the globe. So tens petabyte data they are generating. Okay, 1 TB per day, such kind of. Okay, so what's the solution they use? So for example, this part we can definitely use the structured data we can the Oracle. But what about the semi-structures and other? So for that, there is a one tool that is the HDFS data warehouse, allows storing all the semi and multi-structured data and offer the processing data on the petabyte scale. So this is the vendor was the Cloudera, and cluster and data size was 500 TB of data and tens of petabyte across Nokia, 1 TB per day. Okay, so this is the another scenario. So what is the HDFS? HDF is a Hadoop file system. So it's a file system to store your data. I will discuss it also later. This point of time, the important thing is that you should understand what were the problem and what tool is used for that. I hope it's clear, right? So now I have discussed 2 use cases. So just a quick response from you guys. I hope it's clear, right? Yes or no? Great. Okay. Now let's see what is the big data. We have already discussed what is the big data. Okay, not discussed. We have just quick one response. I got response from you guys. Some people give a good response on that. Okay. So what is the big data? People told lots of data. Big data is terms collection of set. So large and complex data. So it's very difficult to process using on hands database management tools are like that. Okay. So these are the points of the analyzing. So these are just, I'm skipping it, I'll let you know. So here is the some definitions from some companies what they have told us. Okay, so I want to discuss one more thing here. So what is a big data? Which points I will cover in between time. So I'll just here I'll give you some example. So basically big data is nothing. Okay, if I talk about what is this big data, so it's simple means big data is nothing. It's a problem. Big data is a problem. Okay, it's not a technology, not though it's right now in general way we are just using these terms big data for the technology, big data technology, but it's not a technology, it's a problem. To solve this problem, we came up with some different solution like Hadoop, Spark, many other frameworks. Okay, so it's a problem, and it's a problem. How you can say big data? I'll tell you one more example.
Rituraj sir, some question in the chat box. One student
Okay.
has asked that
Okay.
Ansu Sharma has asked.
Okay. Can you? I have a question. I'm just reading it so that all people can get it. Can you suggest some algorithm to access unstructured data? Yeah, definitely. There are many algorithms. The framework like MapReduce. In the MapReduce, we have some frameworks to solve this problem, unstructured data, and in Spark frameworks also. So basically, I'll discuss that. So the programming framework is the MapReduce. By using the MapReduce, we can solve such unstructured problems. Okay, and in normal terms, we have some in a normal programming language. So for example, data if you going for the audio data analysis, for example video data analysis, so we have some certain if I talk about the Python programming language, we have certain libraries like OpenCV, such kind of libraries. By using such libraries, you can analyze the video data, audio data like this. Yeah, exactly. Is data like image, video, audio. Such analysis we can do using the some OpenCV libraries in the Python. And after that, in terms of if I come on the MapReduce end, so there are certain algorithm inside that MapReduce we can use that. Okay, so I hope you clear, guys. Just a quick yes or no. Okay, so I'm moving the moving the next part. So I was just discussing what is the big data. Okay, so see, so I have already told you big data is a nothing. It's a simple problem. Okay, you guys very clear. Okay, big data is a problem, not a technology, not a tool, not a framework. Okay, now let's see when we can say this big data is a problem, when it's not. It's also depend on so we cannot say some so for example there is a problem one. Okay, we cannot say this problem one is a big data from problem for all machines, or you can say for all scenarios. Okay, it can be for some scenario problem, some not. So I'll give you one more example here. So for example, right now I have a single machine. Okay, so this is having a capacity of, for example, 8 GB of RAM. Okay, and it's a 100 TV for 1000 GB of it is having the HDD. HDD means hard disk, so for the storing data. Now I'll ask you one question. There is a some data in a some database. Okay, this is the data one. Okay, this data need 4 GB of RAM. To process this data, we need 4 GB of RAM and 500 GB of hard disk. Okay, so just a quick question: does it a big data problem? No, correct. This is not a big data problem. We can solve this problem using such resources. It's good. Now, in the day two, this data got in the day two. In the day 2, this data got increased. So for example, now it's D2, D1 plus D2, such this data. Now this need 10 GB of RAM, just hypothesis, and 1500 GB of hard disk. Now this is a will we become the big data problem for this system, for machine 1. For this, it's a big data problem for this. Okay, so this is the problem, and this is the big data problem for this machine. But we cannot say for the all around the world it's a big data problem. No. So for example, you have another machine M2, it's have more capacity, for example 16 GB, okay, or you have 2000 GB of hard disk. Now this problem you can solve using this, means it's okay, you can write it and solve it. So this is the problem, this problem we can solve using such way. So this is the big data problem for this scenario, but not this scenario. Okay, so now what happened in someday? Now we have already discussed data is growing day by day. Okay, so after 10 months, so after some time it will be also not feasible to solve this problem using this M2, and sometime later we have to think something new. Okay, so this is the big data problem, big data problem with the growing your data. Okay, now the another terms, if you remember, we have discussed scaling up the system. I have told you that after certain period we cannot scale up, right? So for example, there is a two type of the scaling. I'll tell you, there is a two types of. Okay, so now we can scaling problem is a one is a your this is a vertical scaling, another is your horizontal scaling, and this is a very important concept. Okay, this scaling approach is changed the complete this big data game. That is why your Hadoop, Spark, those such kind of framework is so much popular during this time. So I'll give you what is the vertical scaling. Vertical scaling means you are scaling up the same system. Okay, you are scaling the same system. So for example, this is the M1. Now it is 8 GB. Okay, I'm just taking one example, RAM, not including hard disk. Okay, after some time it's need 16 GB, you can increase this 16 GB. Okay, so this kind of scaling up, you are scaling up the same system. So this is the vertical scaling. Now horizontal scaling means instead of scaling up in the same system, so for example, we have machine 1. Today we need 8 GB. Tomorrow we need suppose 16 GB. We can add one more machine M2 in the same cluster. Okay, so here the concept of cluster is coming, and here the concept of distributed computing is coming. So two basically things: distributed computing plus horizontal scaling. These two things actually change the game. Okay, now let's see. I'll give you just a very uh, simple example to understand this scaling up problem. So and you can remember this thing. Okay, so for example, there is a one farmer. Okay, that is having one ox. So okay, so there is a one farmer having that single ox, and he has actually for example a square feet area of land, and he is working in that. Okay, and just running their your business, farming business. What happened after after some times, it's got some more profit, so it's acquire some more land. So now it's come to a2 a square feet, for example a2 acre, a2 area. Okay, now what now if you see, so what he did, he just so now his ox need to be more work. Okay, need more strength, more power, to work on such new increased land area. Okay, so what he did, he just started giving more nutrition, more good food to his ox. Okay, so ox are also happy. He's getting more nutrition, so he's able to work on such new land. After some time, he increased another time, means A3, now A3 area land. He acquired more lands. Now he again same did. Now he started three times giving three times nutrition, but just it is not feasible. Okay, this ox has such limit to consume nutrition and food also. Three times this ox cannot consume. Okay, so now this is the problem for this. So it's a more work, less resources. So just convert this problem in our data problem. We have more data, less processing. So the resource here, the nutrient food is the processing. Okay, so what's ultimately what he had to done, he had to buy another ox. Okay, so this is the, so giving the more food the single ox, it's kind of vertical scaling. Okay, but adding more oxes, that is the horizontal scaling, adding the more nodes. Great. Okay, so I hope you are clear with this vertical and horizontal scaling. So this horizontal scaling is having in the Hadoop. I will discuss the Hadoop architecture bit later. I will give you, then you will clear how this horizontal scaling is working. Okay, so I hope it's clear. This terms is very clear: scaling up, scaling, this vertical scaling and horizontal scaling. Guys, quick yes or no. If someone not clear with, just tell me. Okay, great. Now we'll go for the next slide. So next slide, that is the big data definitions. So these are the some definitions I'll tell you. So this is the definition given by the gardeners and some companies. So that is telling that big data has high volume, velocity, and variety information assets that demand cost effective innovative forms of the information processing for enhanced insight and decision making. So basically, the if I talk about the glimpse of that, so they say big data is nothing, it's a high volume velocity data and variety information assets, and we need to process it and give some insights so that decision making can be done. Okay, so this is the thing. Now see, okay, now we can see another some points on that. Big data is the term it's not a given any definition. It's, I'll give you, this is the such explanation of the big data problem. Big data is the term applied the data sets whose size is beyond the ability to the commonly used software tools and capture, manage, and process within a tolerable elapsed time. Okay, that if you remember in the last slide we have discussed same thing. Big data is not problem for the certain machines, or you can certain we are not capable to process that. Okay, so such is the big data problem. So here is the next points is the what are such kind of data could be. It could be a web logs, sensor network data, social media posts. You remember how many comments we are doing every day. Okay, so these are comes all in the big data problems. Okay, internet text and document, internet pages, search indexes. Okay, atmospheric science means we have some weather information. So for that, you cannot means imagine every second we are getting so much sensors data. Okay, some scientific research, military surveillance. Okay, so such kind of these are the examples of the sources of the huge data which we are getting. So these are the uh, combination of the different data types or formats also. Okay, now what are the
Sir,
complexities? Yeah.
sir, we have a
Yes, sir.
question in chat box.
Okay. Velocity means accumulation of the data at faster rates. Correct. It's not. Yeah, it's a two-way thing. Velocity means we are getting a data day by day so much rapidly. This is the one thing, getting the data. Another problem is also velocity is also problem to processing the same data at the same velocity rate. So, for example, just example, for every 10 minutes you are getting some data. Okay, so it is also important you should process that data within a 10 minutes, otherwise it will be over backlogs, your backlogs of the data. I'll give you one example for that. So you are going to the ATMs, right, and you are just swipe your card, you withdraw some money. Okay, so within a second you are getting the message that such amount of you debited from account. Okay, if such data, if the velocity of data is changing in data is so fast, and if you are not getting the response at the same time, then this is the totally useless. For example, you detected money today and you get the message of 10 days, after later 1 hour, 2 hour, 5 hour, then what's the use of that? Within at that time, if something has happened, you don't know. Even for example, some another person or some hackers and some fraudulents use your card, but you will get information after 5 hours, 6 hours. So this is the point of complexity, point of the velocity. Okay, so velocity is not only for the consuming the data, or you can say accumulation of the data, it's also processing of the data. That is also complexity with that in both ways. So I hope it's clear. Does it make sense, Gaurav? Gaurav, does it make
Yes.
sense?
Yes, sir. Sir, we are getting responses.
Okay,
Thank
okay,
you.
sure. Okay, okay, okay. Now we are going to see the what are the three V's. Okay, so three V's means these are the what are the complexities. So basically here I put it the three V's. Now in some authors are using five V's, six V's. Okay, but primarily focused on this. They also, you know, these are the common category. They also divided sub categories from these categories. So basically three V's is the first uh, the first V is your volume. So volume, we have talked about this part already. Okay, volume means the size, amount of data. Okay, amount of data generated. So this is the volume. This is the one complexity with the big data. Today we have 10 TV. Tomorrow we'll have 15 TV, like that. So it's a volume. Another problem is the speed velocity. So I have already discussed with this. So speed is generating the data. Is so just a simple way. Velocity means speed to generating the data, speed to consuming data, speed to processing data. So these three part is there. So velocity means this thing. Variety means we have a different types of the formats, structures, unstructures, audio, videos, okay, text. So such kind of, so these three V's of the big data are important. So what are these three V's? Three V's basically what are these complexity coming with the big data. So these three V's, for that we have categorized the different level of the complexity of the big data. How means we can divide a big data problem. So this is the one problem, volume. Another problem is velocity. Another problem is variety. Okay, so such is the problem. Some other, there is a some problem is the accountability also, verification. Okay, veracity, such kind of problems also there. So you should be, you know, data should be, it doesn't mean whatever you process, that should be you know present in the same information present in across all your reports, or you can say across all your different notes. So that is also another problem. Okay, so but category but commonly we can say these are three V's of the big data. Somewhere you will get five V's, six V's also. Okay, so I hope you guys clear with this part. What are the three V's? So basically these three V's for the, you know, complexity of the big data. That for that, just quick yes or no. Okay, so just move forward. So now what are the solutions for this big data? We have seen big data problem, right? We have seen big data problem. So what is the solution of this big data problem? So solution wise, the first solution come in, I'll tell you, this is the Hadoop, what we have known right now. But before Hadoop, there is a some actually Google primarily submitted one paper on that, this big data. So for the processing the data and storing the data. So there is a GFS, Google File System. They put some research paper on that, white paper, and after that this implementation start, and there is a Hadoop comes in the picture. Okay, so if you see, this is the slide for the Hadoop, what Hadoop looks like. So this is the logo of Hadoop. Okay, and just see, I just pick up this information from the Hadoop's official side, so that you can get it complete idea what is this Hadoop. So Hadoop is nothing. Okay, Hadoop is a simple framework, which accommodate your big data problem. So how it accommodates big data problem, we can get an idea by just reading these things. If you see, this is Hadoop is a framework that allow the distributed processing of large data sets. So first thing, if I noted here, what is this? This is the distributed processing. Okay, so distributed processing, this is the first thing comes in the picture. And another thing is large data stores, clusters, and computer using the simple programming model. Simple programming model. So here I will discuss this. It designed to scale up. Scale up. We have already discussed what the scale up problem and what are the different type of scaling approaches. Okay, and I also give you a point that this scaling horizontal uh, horizontal scaling give a big hype this Hadoop thing. Okay, so scale up from the single servers to the thousands of the machines. It's this is the game changer thing. So in Hadoop, for example, in Hadoop cluster means there is a one setup that there is a some, you can say, master node, and there are some slave node. These are your slave nodes. So this is come we can say this complete setup is a cluster. So all these connected with this like that. So this is the cluster framework. So scaling up, so means today you need for example 4 node, tomorrow you need just add one more node in there. So it's very easy actually. In the Hadoop you no need to go and transfer the data from one server to, for example, in the RDMS, right? If you have this server capacity of a capacity, now you improve the server with the B capacity, then you have to move your data, everything. So it's quite difficult. You need a special person. But here it's not so much difficult. You just add another server. In the name node there is some configuration files. You just give the details this data node, or you can say the slave node, and it will be just plug up. It's kind of plug up things. Just plug in and just start using that. No more time. And all these nodes are the commodity servers. Commodity servers means very cheap servers. It's not required very high end servers like supercomputer something. It even in your for example your systems also, you what PC we are using, we can just connect to more 4 5 PC and we created this Hadoop cluster. So this is the another game changer thing. These are the commodity hardware. So each offering local computation and storage. Local computation time is each node is having their own local computation and storage also. I will discuss this architecture bit later. Okay, so rather than rely on the hardware to deliver high availability, the library itself designed to detect the handle application layer, so delivering high level of the service top clusters of computer. So basically 3 points comes here. The first thing is a distributed computing, second thing is a seamless scaling up approach, and third thing is the your community hardware, you can add it very there. So this makes make your Hadoop so popular. I hope it's clear. So what is the Hadoop? Hadoop is nothing. It's a simple framework to solve your big data problem with by implementing some best approaches: distributed computing, scaling up approach, good scaling up approach, and your uh, MapReduce framework, processing framework. Okay. Now just go into the another slide. So it is not so much related to a topic. So I'll just give you, it will give you just idea what is the how Hadoop evolve and how we develop this Hadoop. So basically the developer of Hadoop is the Dow Cutting and Mike's. So if you see my screen, this process will started at 2002. So there is a Nudge project. They started working on this Nudge project, and after around 2003, Google actually released the GFS, Google File System, white paper on that. And after 1 year later, Google released the paper on the MapReduce. So MapReduce for this Hadoop framework is a MapReduce. We can say this is the for processing. Okay, this is for processing, and this is for your storing. Okay, so this is the processing framework MapReduce, and this is the storing, you can say, framework or setup, Google File System. Okay, after that they implemented this NDFS, and if I go in the more timeline later, so around 2011, okay, 2011 we get the first stable official Hadoop 1.x version. Okay, and after later they improved it. There are some architectural changes, some more, they added more facilities, libraries, more and they changed some programming processing approaches also here. So these are the different versions comes in the picture. So right now in the industry, we are using 2.x and 3.x. So if you guys going to start learning, so just skip this version. you can start this version or you can start this. Better if you start 3.x, because for example, if today you're going to start, it will take for example 2 months or 3 months to get expertise on that. So definitely they will start migrating industry on this version. So just suggest on this, or you can run on that. So there are no major change in the working with this, but it's have some addition. Okay, you can learn from here also. There are no drastically conceptual changes. There are some library changes, some framework related changes. They did it. Okay, now the time of just I'll take some 2 or 5 minutes pause, and I'll take your questions if you have any question till now. If you are clear with me, or you have any question till now what I have covered. Just a quick, if you have, that's fine. Otherwise we can go for other, we can see what is the Hadoop and other framework. GFS means Google file system. Google submitted a Google submitted a research paper on the file system. I will discuss this HDFS, then you will get such sort of idea what is the GFS. So this HDFS is you can say it is the spirit to develop the HDFS comes from the GFS. So motivation of HDFS is GFS.
Yeah. Hi, sir. Hello.
Yeah.
Sir, can you please rate an example of big data from AWS services? How they manage the applications, big data application on AWS services? Can you please rate an example?
In the AWS, actually, if I talk about the Spark services, like so, there is a EMR services. For the Spark, there is a EMR service. You can use that for your, processing the big data using the Spark engine. Okay.
Okay, sir.
Yeah. So this Nudge project is nothing. This is the name of the Nudge project. Basically, they started to solving the this big data problem. So what is the initially they started? That is the name of the project. So that is projects just to adhere the big data problem. So they the guys dog cutting and this Mike, they started working on that project. So this is also same as per the this GFS, or you can say MapReduce thing. So basically this Hadoop project is the sub project of the Nudge project. Sub project means, for example, just I'll give you a simple example. So you are going to work in some project in our academics, right? So we started some simple idea, means for example, some ABC person is a part of the 4th year batch. Okay, and he started on some project. He have some idea. Okay, some problem he's solving. So he started working on that. After that, some next batch will come. Okay, they see and they also enhance that project. So they just create a sub project under that project, or you can say some module. So whatever we have learned from that project, we are implementing some project. So that will comes like same way like this Hadoop comes in picture. So they started definitely solve this big data problem only, but after that they seen this thing, then they launch the sub project, and after that they give this project to the Apache Foundation, so that it will be a freeware. So Hadoop kind is a freeware project. So they give it hand over to that. Now the right time, this time this Apache Foundation is managing this Hadoop versions what we are getting in the public domain. I hope it's clear. Okay, so guys, just if you have question, just type it. Okay, Now I think we can move up in the next slide. We'll see some Hadoop's more stuff. Okay, just give me a moment. So you can see my screen. Now you can be, see these all are the component of the Hadoop ecosystem. So we called it the Hadoop ecosystem. I just added different tools for the Hadoop. Okay. So, but you are very confused. What is this Hadoop? So many things, so many tools, and each tool have different, you know, its own specific use. We cannot use everything everywhere. So I'll just start with this Hadoop things. Okay. So so make it very simple. Basically, the core part of Hadoop is only two things. So first thing is HDFS. Another thing is your MapReduce. MapReduce. So basically, if you see, this part is core Hadoop. I will tell you what is this ARM and when it comes. So initial version, I can talk about the 1.x version. In the 1.x version, Hadoop have two part, HDFS and MapReduce. In H2.x, what happened? They just make it this MapReduce. So for example, this is HDFS and this is your MapReduce. They split this in two part. One is MapReduce and there is yarn. I will tell you what is this yarn, what is this MapReduce, and why they split it. So basically HDFS, I'll just give you one simple example. To process any data, what we need some database, or you can say some data. To process any data, we need two things. First thing is you need some storage thing to, because if you want to process any data, definitely you have to store it somewhere. You process it, and after that you store it somewhere. So we need storage. I'll just making it the general point, storage. And to process data, we need some programming framework, or you can say some processing framework. Correct? So in normal OS, we have file system. In normal OS, in normal fashion, we have different programming, C, C++, Java, like that framework. Or you can say in Java also we have different framework, right? So such way we have different framework. Here, this is comes in the Hadoop. It's a MapReduce. Okay. In Hadoop, it's a MapReduce, and so we have file system, and I already talked you Hadoop using the distributed approach. So it is using distributed file system. Just put H before that, so it's became the HDFS. So this way HDFS comes in the picture. So HDFS is Hadoop file system. Simple. So Hadoop is combination of two components, HDFS and MapReduce. This is the 1.x. Now Hadoop is a combination of three components, HDFS, yarn, and MapReduce. Now you will ask, what are these things? Why these are here then, if it is not Hadoop? This is the Hadoop ecosystem. Ecosystem means by plugin, or you can by installing these different tools. Okay, by using these different tools, we can install these tools on the top of HDFS layer, or you can say on the top of Hadoop layer. Okay, so I'll tell you why we use these things. Now the another thing, I'll just give you what is the quick notes on this. So MapReduce, yeah. So in the 1.x, MapReduce is doing two jobs. The first thing, it is a processing framework. It is a programming framework. We write the MapReduce program, MapReduce jobs, to serve our process, to serve the data processing. And it's also a cluster manager. Cluster manager means it's also managing the cluster, means which data is coming, which node, and which node is down, which is up, such kind of resource management, you can say. This is also taken care by this MapReduce itself. So in the 2.x, they make it another part of this AR. AR means yet another resource node manager, negotiator, yet another resource negotiator.
Sir.
Yeah.
Rituraj, sir, sorry for interruption. The session was going very good, and I think we are must engaging. We are running out of time. I think so. So the
Oh,
students are
yeah, yeah,
leaving.
correct.
So
Okay, okay, sure, sure,
basically,
sure.
we are arranging a separate meeting for this. So the meeting is very good,
Actually,
interesting.
the session is so interesting that don't have information
Yes,
about the time also.
Okay,
And
so
I'm
give
just
me,
checking that
okay.
that is
we will,
over.
Sachin sir,
Yes,
we will
Oh,
plan, I think, some
yes,
other lecture for Rituraj sir. I
yes, yes,
request
yes.
Rituraj sir to take another session if you are
Totally.
okay,
free
so,
and you are
so
available.
no, no. So this is not much. I'll take it 10 more minutes. Within 10 minutes, I will wrap up this part. Okay, technical part. If it's fine, is it
Yeah. Please carry on, please.
okay?
Yes.
So
Okay.
okay, quickly I will wrap up. So this is the yarn. So what are these services? So this is the. So these are your processing framework. So these are Spark, Mesos, and these are processing framework. This HBase is database. Storm and Kafka. These are the real time services to take up the real time data. Okay, so Scoop is data ingestion. Hive is your something kind of like a SQL. So if you have any data in the HDFS, so query that we can directly use this Hive. So these are things. OZ and Gcooper, Zookeeper is your configuration manager, and this is the scheduler to schedule your job. So this is the kind of Hadoop ecosystem. I hope it's clear. Now, we have already discussed how we handle such a limitation by giving the scaling up thing, seamless process and accumulating data, map reduce, using the map reduce, just merging a data. So here a quick example. That means I'll give you how we solve some problem in the Hadoop way and traditional way. So this example simple the voting system. Okay, so in a, in uh, in our area, if we have some voting part, so different zone are there. They just do their ballot box. So what they are doing, they are just taking that ballot box from different, for example 4 nodes are there. They are taking that ballot box from there to the common area, and they count, then they declare the result. But the Hadoop way is, we will count the ballot box at the same station. We are not collecting it in common, and after that we will just count, merge all the countings and declare the result. So this is the same way of the Hadoop. If you see, so this is the architecture of the Hadoop. This is the your master node. These are your data nodes. Okay. So and in Hadoop, another thing, we are replicating the data more times. So same data is replicating 3 times, and this is a configurational. We can configure it 2 times, 3 times. So each node is, in this Hadoop is the important thing is, we are not sending this data to the name node or main node. We are sending the program. We are sending the program, map reduce program, to each node. So that program will run on the each node and get the result, and that result finally, got the accommodated, and then it's declared the result to the your name node. So this is happening in the Hadoop. I hope it's clear. So till now, I hope I have covered this Hadoop thing. So it's clear. Now come over the, so there are certain limitation in the Hadoop. We just overcome these limitation. You know, those limitation is taken care in the Spark framework. So if you see in the Spark, so in Spark, uh, actually, if you see, these are component are the inbuilt in the one system. They are not different to install in Hadoop. We have to install different for specific call. So this is the simplest approach of the Spark. So this is how Spark so Spark is much faster than Hadoop. And right now in the industry, I will tell you, if you are going to learn something, just go for the learning the Spark. Hadoop, you just know the basic understanding of the Hadoop, but start learning on the Spark. So I have so in Spark, RDD is the one thing. So I'm just skipping because this is not much relevant right now, which our scope is not in that. So now the main thing is how to be industry ready. So I just take your 5 minutes. So industry ready, there is a role. I will discuss some roles. Okay. Okay, so well, starting the most important part, roles in the industry right now, it's a data developer, ETL, and your data engineer. You have heard about data engineer. Okay, so the work of these is data developer is simple. You can working on the data, developing your data. So all more all the same way. So data engineers work is it is taking the data different sources and build up one pipeline and give that data to your operational system, for example data science team, other team. So it's working with the working like a bridge between the data points data and your other downstream teams. For example, this is your business team. Okay, some transactional data here, business teams are there, they are selling some product, and we are collecting that data and sending to the some data science team. Okay, our downstream team are generating the report. So this is the role to building this pipeline and maintaining this pipeline. That is the work of the data engineer. Even in other terms we are calling it the data plumber also. Okay, so this is the way. So I'll give you example. So in the Amazon thing, you people are going to shopping some products. Okay, so what is the role of data engineer? And suppose you also getting some sometime you get mail, this is recommended for you, you are recommend. Okay, such kind of mail recommendation system. So that is also developed by some data science team. They run some models, your machine learning algorithm on that using the dead data. So data engineer's role is just collecting that data, product data from the sites, and just build up some pipeline, and through that data will go to the data science team, and they will run their own model on the top of that and generate the result. So such kind of full view. So if I talk about this prerequisites, okay, prerequisite for this big data learning is you have to if I there are two in industry right now. We have two types of companies. One is the service based, and another is the product based. Product based like Amex, Ameriprise, okay, such kind of. Service based means like that CTS, Bipro, TCS, like that. So in the I have already worked in both companies. So product based approach, for the products based companies, you have to first requirement is the you have to understanding of the data structures and algorithm. This is the first thing. Just keep a note. Without data structure and algorithm understanding, you cannot crack any this product based company interview. You have to that. Second requirement is the SQL. SQL is very important. Usually what happened in my student life also, I ignored that SQL. Usually we ignore that SQL. We just most focus on the some other thing, machine learning and networking. So those are actually fascinating things, but we ignore that SQL. So that is very important, because all about in any industry you will go, you will deal with data only. Okay, so right now so second requirement is you have to build up concept on the SQL basic concept. You can pick up any tool, means any tool means any vendor, Oracle, MySQL, or PostgreSQL, anyone. Take one. You we are not expecting you should have expertise in everything, but you should have basic concept of the SQL using any one programming language, using any one vendor tool, for example MySQL, PostgreSQL, anything. And third thing is the one programming language. I told you this Spark, actually this Hadoop is built up on the Java. So if you are going to be expertise in the Hadoop, then go for the Java. And this Spark is written in the Scala programming language, and it is working on the, and you can run your program in the Spark using any program. Any means you can run a program in Java, you can write in the Java, you can write in the Python, you can write in the Scala, you can write in the R also. Right now it's supporting R also. So I will suggest pick up one programming language for this Spark, either Java or Scala or this Python. But if you are going to learn from scratch, then better you go for the Scala if you are going for the Spark, because data engineering profile hard code. But eventually after some times, if you go into the bigger level in the industry, you have to get knowledge of all programming language. Right now in my project I am having Java projects also, Scala also, Python also. So at the but beginner level, choose one programming language, Python, Scala or Java. That is your choice. If you are going for the Spark, I will suggest go with Python or Scala. Python is easy to learn, and in Spark is a PySpark. And if you are going want to go into the MapReduce and this Hadoop thing, then is Java. But I will suggest right now, if you are going to start learning, learn the Hadoop architecture and Hadoop concept, because Hadoop is the mother of this Spark, you can say. And go and do good hands-on on the Spark. I hope it's clear. So these are the my points. And also in my slide, if you anyway in future, if you want to connect with me, so this is my LinkedIn profile and this is my email also. So you can connect with that. So I hope for today, actually, I also want to show you demo, but I'm running out of time. So I'm just pausing it. In the next way, whenever I will go,
We will
I will
have
try.
next session. We will have next session. Surely we will have the next
Definitely,
session.
definitely.
And we have
So
to plan. We have to plan. I think some more sessions from you, the series from your series only. I am
Yes,
very
yes, yes.
impressed. I am very impressed with the knowledge you have, and you have answered the students' answer in a very good way. So I
Yes.
think
thank you, sir.
I hats off you because there are so many students are there. I want to tell you that today the time at the in the Singapore is now today is the midnight. I think so.
Yeah, it's
Yes.
So,
11:30 around.
so in the midnight,
11:30
in
around.
the
Yes.
students, I think switch on your cameras. Those are present, please switch on your cameras and big clap for sir, because in the
Yes, yes.
Singapore in midnight, he is giving the such precious knowledge to us. So
Yes, yes.
we must have some motivated. We must have self motivated. The
No,
person in
it's
Singapore in
my
midnight.
pleasure, and I always ready to help you guys. Anytime
Yes.
if you need any suggestion, anything, just drop me email. Okay, so I will respond it, and eventually I will also I am also taking the some sessions in in my organization also. I am aligned with the academy and just taking the even I taken the across the globe sessions. So any team is coming from the big data or something, so initially I took that program, the training program. So for you guys also, it's okay. Anytime you can just drop me email. I will suggest you whatever the resources you are getting. Another point I will tell you, you people are following the website. So this time in the internet, you will get the lots of data, lots of resources, and definitely that will confuse you. You will if you go. So I will suggest you pick. Don't be someone ask you this is good, this is bad. Everything is there. Pick up one thing, one ebook or one thing. I will suggest you, if you go for the learning spark, that is written by the Mathia Jatai. So he is itself the inventor of the spark. So I'll suggest you learning spark is a ebook for that. And another book is the Hadoop. The name I'm getting forgetting, this Hadoop in action or something. So that is also good. So pick up anything and start learning with that. So
So
that's the thing.
I thank you again. Thank you, Rituraj. And I'm very
Thank
impressed. I motivate my faculty members and students also that one person is working in the midnight and we are at the 8 p.m. only or 9 p.m.
Yes,
only
yes,
here. So
yes,
thank
yes.
you and thank you. I salute your
Okay,
dedication.
sure.
Yeah.
Thanks, sir, and means inviting me. I'll really thankful to connecting. Actually, I feel some more excited and motivated to connect with the students and sharing my experience. So
Okay.
I'll tell
Yes,
you
yes.
one thing. I didn't take anything. I learn here, so I want to give it here also. That's the
Yeah,
thing.
thank you.
Yes, yes.
Thank you.
This
But
is this is your
that's
good
we
night.
are also doing.
Yes.
I request Sachin sir to give formal vote of thanks.
Okay.
Yes. Basically, the time is very running when, and basically the even the this webinar is very interesting. So, Rituraj sir, I am here to present both of thanks for the today's session, and the session is very full of knowledgeful and the interesting facts. So, thank you so much, sir, for taking out time from the busy schedule. Thank you, sir, and thank you for all participants whosoever joined till now at the end of the session. Basically, it represents your dedication about the learning. Thank you, sir,
Thank
Rituraj
you,
sir.
sir. Thank you, Sachin sir. Thank you, Rama sir.
Thank you,
Yes.
sir.
And
Thank you,
thank
sir.
you more students, guys, friends, all you. Anyway,
Yes, if
anytime you
you have
get
any
any
question,
question, just drop me an
yes,
email. I will take time
yes,
if
or you
needed.
can,
If I
yes,
yeah, and in the future, if I'll try to conduct any session from anywhere, then I will definitely call you guys. Okay.
Okay,
Thank you, sir.
thank
yes.
you,
Have
sir.
a
Thank you.
good night. Bye, sir.
Good night, good night,
Bye.
good night.
Bye.
So, thank you.